Welcome to Differentials Applied Part 2. All right, here's our first problem. The current in a resistor varies according to I equals 0.08 T raised to the 6th power minus 0.04 T raised to the 2nd power. Find the approximate change in current using differentials as T changes from 2 seconds to 2.1 seconds. Okay, so we know that I is equal to 0.08 T to the 6th power minus 0.04 T to the 2nd power. So we're going to take the derivative of that, derivative of I in relation to T. So we get a di dt is equal to 0.48 T to the 5th power minus 0.08 T. And we simply take the t and move it over to the other side of the equation, giving us di is equal to the quantity is 0.48 t raised to the 5th power minus 0.08 t in quantity times the change of t, the dt. So we've got a di, the change in I now. We just do the math. We're going to put in 4t is our first our initial time, so 2 seconds goes in for t. And the change of t is the difference between 2 seconds and 2.1 seconds. So that's the 0.1 seconds for the change of t. And we end up with 1.52 amps. So there's a change in current of 1.52 amps from the time 2 seconds to the time 2.1 seconds. All right, here's another question. A freely falling body drops according to S equals gt squared divided by 2, where S is the distance in meters, g is equal to the effects of gravity, 9.8 meters per second squared, and time is time in seconds. Approximate the distance, ds, or change in distance, that an object falls from time 10 seconds to time equals 10.03 seconds. Okay, so we want to know the approximate change of distance between two specific points in time. So we know that S is equal to g times t squared divided by 2. So we can rewrite that equation so it makes it a little bit easier to take the derivative or to see the derivative. And that's the same as saying 1/2 times g times t squared. So now we can take the 1/2 times the 2 is going to turn into 1. So we know that the derivative ds dt is equal to g times t. So again, we're going to move the change of t over. So we've got ds, the change of distance, is equal to g times t times the change of time. That gives us ds is equal to 9.8, which is what g was, times time and the change of time. Our time is 10 seconds. Our change of time is the difference between 10 seconds and 10.03 seconds. So that's the 0.03 seconds. And that gives us a change of distance from time equaling 10 seconds to 10.01. The change of distance from those two sets of time is equal to 2.94 meters.